Hello everyone. In this lesson I am going to show you how to apply different type of timers in TIA portal in two different languages, Ladder Logic and SCL. Okay, before I start showing you how to apply different type of timers, I need to create my default tag table. To save time, I have already created my default tag table. I need obviously two inputs. The first input is the start button, which is the Boolean address, I0.0. And the second input is my reset button or the stop button, which I can reset my timer anytime that I want. And again, it is a Boolean input, I0.1. I need two motors as an output. The first motor, I am going to use it in Ladder Logic, Q0.1. Again, Boolean address. Motor number 2 is the second Boolean address and is Q0.2. For the two timers that I am going to apply in two different languages, I provided two memory double word, one for the first timer, which shows my current time value when the timer is running. Okay, so MD stands for memory double word. I started with number 20. So the next available memory double word will be number 24. So it increases by 4. Why? Because each memory double word includes 4 bytes. Bytes number 20, 21, and 22, 23 are already being used in memory double word number 20. So the next memory byte is number 24. That's why the next memory double word starts from number 24. And it increases by 4 to the next one, which is 28. And again, increases by 4, which is the next one is memory double word number 32. So the first two memory double words is showing my current time value on each timer in Ladder Logic and SCL. And if I want to change the preset time while the program is running, I need to create two more memory double words. Okay, one for the first timer, the other one for the second time. Okay, let's go back to the main OB1. We are going to test the timers now. We are going to insert a network in Ladder Logic. So first we are going to test the timers in Ladder Logic. I am going to start with a TP timer. TP stands for pulse timer. Okay, so you just need to drag and drop simply. So when you drag and drop, it asks you if you want it to be addressed automatically or manually. I don't need to address it manually, so I accept the automatic addressing. I press OK. So each timer is a data block. So the first timer that I apply is DB1, data block number 1. Okay, so obviously I need an input for my timer, which is going to be my start button. And I need obviously an output, which is going to be my motor number 1. Okay, and PT or preset time. Okay, so in this case, we have got two different options. If you wanted to set the timer for a specific time, for example 10 seconds, okay, and you don't want to change it, you just type 10S. So 10S stands for 10 seconds. If you want to change the timer for 10 minutes, simply just type 10M, which stands for 10 minutes. If you want to go for 10 hours, 10H goes for 10 hours simply. Or even, for example, milliseconds, MS goes for milliseconds. So it depends on how long time the timer should be running, you just set a time here. So for now I am going for example, 10 seconds, 10s. So in this case, you cannot change the preset time when the program is running. If you want to change it, you need to use a memory double word here. So while the program is running, you can basically modify the preset time. ET is my current time value. Okay. So current time value number 1 is for the first timer in ladder logic. So now I can run the timer. However, this timer doesn't have any reset button on it. So if you want to reset the time at any time that you want, you can apply a reset timer from here. So you can see this option here that I've got is the reset timer. Okay, so you can just drag and drop it into the second network. And of course, the reset timer requires an input, which I am going to use my reset button. And then, which timer I am going to reset, obviously is this timer, DB number 1. So simply if you click on the window, you can find DB number 1 here. Here you go. Click on it, sorted. So now simply I can download the program to the PLC, load it, and now if we monitor the program, simply we can test the program in this case. Okay, so now if I press the start button, so TP time is a pulse timer. Okay, if you want to get more information about each timer or each kind of function that you apply in TIA portal, if you click on that specific function and press F1 on the keyboard, then it gives you all the information about that specific function, which in this case is a pulse timer. So you can see all the information in the guidance, okay, or in the information system. However, you need to have access to the internet, otherwise you won't be able to do that. Okay, so now I'm going to press the start button. Okay, so now if I press the start button, sorry, I pressed the reset button by mistake. If I press the start button, you can see the motor turns on for 10 seconds and then it turns off. Okay, so simple as that. However, now you can see my start button is still high. Okay, so the pulse timer works with a high input. Let's see, does it work with a momentary input or not? Now I am going to press the start button momentarily. Turn it on and release the start button. So now the start button is low, but you can see still the timer is running in the same way. So there's no difference for a pulse timer what kind of input is going to be used. Is it a momentary input or a latched input? With both inputs, this pulse timer is going to run the output for a specific time, which is 10 seconds in this case. However, we need to know it only works with it works with the positive edge of the input. In the previous video, I have already explained about the positive and negative edges, and I'm sure you know already what is a positive or rising edge and negative or falling edge. Now I want to reset the timer while the timer is timing. So in the middle of timing, I am going to reset the timer by I0.1 or reset button. So simply by pressing the reset button, you can reset your timer. Okay, Now I want to change the timer to a different timer, and that's going to be my off delay timer. Okay, now I am going to basically download the program. Any changes that you make, you have to download it again. Here you go. You also could delete the previous timer and drag and drop a new timer here, which there is no point, so I could just change it from here. Right? So now I am going to test an off delay timer. So off delay timer works quite similar to a pulse timer. However, there is a difference. So this is off delay timer. Again, now I want to test it. So it sets the timer, the output high for a specific time, 10 seconds, and then after 10 seconds, it turns the output off. But what is the difference between off delay timer and a pulse timer? You're going to see it here. I am going to turn the input high and keep it high. Here you go. So now you can see the timer is on, the output is high. However, the timer is not timing. Okay? It will start timing as soon as the input goes low. So in this kind of timer, it works with the negative edge of the input, or falling edge of the input. So as you see, as soon as I turn my input off, okay, the timer starts timing up. Keeps the output high for 10 seconds and then shuts down. Okay, so as you see, it doesn't work with the latch input. When the input goes low from high with the falling edge or negative edge, the timer starts timing. Again, at any time you can reset the timer, same as pulse timer. So this time I am going to set it momentarily. Here you go. Now the timer starts timing up. Anytime I can reset it by pressing the reset button. Simple as that. Okay. Now I want to apply a different kind of timer, which is T-on. T-on stands for on delay timer. So it's the opposite of T-off. T-off is an off delay timer. T-on is an on delay timer. So now I am going to download the new timer into the PLC and load it, finish. Okay, and now if I monitor the program, simply I can test it. So let's have a look how an on delay timer is working. So obviously it turns on the output after 10 seconds. Let's test it. I am going to turn the input high and leave it high. Okay, the input is high. The input has to be latched, otherwise the timer doesn't work. So you can see, wait for 10 seconds, then after 10 seconds the output turns on. Now if I turn the input low, the output turns off with the timer. Here you go. So actually the on delay timer relies on input, and the input has to be a latched input. It cannot be a momentary input. Okay, so now I want to test it. I want to test it with the momentary input. Input goes high, then goes low. You can see the timer turns off. So the input has to be latched. Okay, and now I can reset it at any time by pressing the reset button. Okay, and now if I release the reset button, the timer starts timing up again because the input is high. Okay. Okay, so that's how an on delay timer works. I have a task for you in this lesson. So I want to ask you to try and test the very last type of timer. on your own and see what is the difference between T on R and T on. So again, this is an on delay timer. However, this is a retentive on delay timer, which I want to ask you to give me information about the difference between T on R and T on. Okay. So that's going to be your task for today, but I am going to show you how to apply a timer in SCL language. So you need to insert SCL network. We can delete the very last network in ladder logic. We don't need it. Again, simply, I am going to change the T on in, actually, yeah, to a TP timer. So I'm going to use another TP timer in SCL language. Okay. Sorry, I need to click on this network and then TP can be in SCL language. Okay. So, in this case, simply you can see the difference between TP timer in ladder logic and a TP timer in SCL. Actually, there is no difference. You need an input in ladder logic for the timer, and you also need an input here, as you see here, which in this case is going to be my start button. Simple as that. Okay. PT, preset time. Here I set it for 10 seconds. Simply I can set it for 8 seconds. However, in SCL language, I cannot just type 8S. Okay, in this case, it wouldn't understand it. As you see, it comes up with a red line below my S. It wouldn't understand this. It has to be right exactly in the same format. So it starts with timer, shift, and then 8S. So in SCL, you have to write capital T, timer, shift, then 8 seconds. Now you can see it is accepting my preset time. So again, we need an output, same as in ladder logic. You needed an output, which was my motor number 1. So in this case, I am going to use my motor number 2. So as I have already used motor number 1 in ladder logic, I need to use a different address for my network number 3. And then again, ET, elapsed time, or my current time value. I use current time value number 1 for ladder logic, and here I am going to use my time value number 2 in SCL language. Right. So now I created my pulse timer in SCL language. However, if I need to reset the timer, of course, I need to write the program in SCL. So in ladder logic, we created the reset in a separate network. In SCL language, we can use the same network for basically reset. So you have got your reset timer here at this point. Simply you can drag and drop it into your SCL network. So I want to reset the timer when my reset button, or I0.1, is high. So in this case, I need to create an if function. So I said if my reset button is high, then reset my timer. But which timer it is? It's going to be data block number 2, the second timer, which I created it in SCL language. So you know already after any function, we have to close the function with end if. Okay, semicolon, sorted. So now our program is completed. Simply we can download the program and test it. So we can download this to the PLC, load, and now we can monitor the program. Okay. So, okay. So now simply we can test the program in SCL language. As soon as you see, the start button is false, so it's not active yet. So therefore the output, the motor, is false as well, and the result is false, obviously. The reset button is not being pressed anyway. So now I am going to start to press the start button. As soon as it changes to true, you can see the motor starts running. For how long? For 8 seconds. And after 8 seconds, the motor automatically will shut down, will go false. Okay. Again, I am going to start it, and now the motor is running. I am going to press the reset button. The motor turns off. So that's how you can apply a timer in actually in SCL language. If you want to be able to change the time when it is operating, when the timer is operating, so instead of using 8 seconds or a constant number, okay, so you can use a data block. I provided preset timer 2 for the second time in SCL language. So if I use a data block here, sorry, I apologize, a memory double word here, anytime I want to change the preset time value, I can do it when the timer is running. So now I am going to download my program as I made some changes here. Load, and now finish. Okay. If I run the program, so now you can see the program is running in this case. So now, anytime, if you double click on the basically preset timer, you can enter a different value or modify the value. So for example, in this case, I am going for I don't know, for example,